Okay, I'm Mr. Radford. This video is going to be on empirical formulas. Empirical formulas are the most reduced form of a compound. Okay, so here are some examples. These are molecular formulas. These are actual compounds. Hydrocarbons are probably the best ones to kind of demonstrate and show this. We have ethylene, which is used in plastic production and agriculture to ripen fruit. But its molecular formula is C2H4, and we've talked a little bit about this, that really we want to try to reduce most compounds to their most simplest form, and that's what the empirical formula is. But in reality, there are actual compounds that do not get reduced, and ethylene and butene are examples. So butene is C4H8, it would reduce to CH2. And this is used in gasoline and rubber manufacturing. But anyway, these compounds, their most simplest form, when we might get measurements from a lab or collect data from, let's say, the air, for example, and we might get the percentage breakdown of different elements that show up, and that might tell us its empirical formula, and then later on we're going to see that we can use that to then get to which form of that compound we're talking about. So to do this, we need to have three main rules that we must follow. The first thing we must do is we're given percentages. We take these percentages, and this always adds up to 100%, right? So it's easy conversion. We're going to take these percentages, and we're just going to erase them and turn them into grams, okay? After we turn them into grams, then we're going to convert to the mole. So the mole isn't going away, so we have to do a unit conversion there. After we solve for the moles of all of the elements that are there, we divide all of the values by the smallest number, okay? Now, after we do that, then we analyze the ratios. We write the formula. Slight rounding is okay at the end here now. So, but one thing we must keep in mind, and that we can only have whole atoms, whole numbers. We can't have like 0.5, 0.4, 0.3 of an atom. So that's why the slight rounding is okay. We're going to talk about, if we get specific numbers at the end, what to do to make them whole numbers. Okay. So our example here is we get a measurement, and it's 73.9% mercury and 26.1% chlorine. Okay. So to do this, we are going to grab our periodic tables. We're going to convert these both into grams. So we're going to have 73.9 grams, and I'm going to convert this to moles. So 1 mole of mercury, okay? And then this, if you remember, I have to have grams of mercury, okay? Where does this number come from? It's off the periodic table. So 1 mole, if I had 1 mole of mercury, its molar mass would be 200.5. That is its molar mass. So when I take these values, taking my cheat sheet, already calculated these out, okay, 73.9 divided by 205. And also, by the way, I'd be remiss to not tell you, pause these, rewind, okay, try them out on your own. I'm going to do this example. Maybe you could try this example and see what we get. So, okay, when we do this, we get 0.3685 and a bunch more numbers. Okay, we're going to keep those values as much as we can. And so that would be moles of mercury. Okay, I'm going to do the same thing now with chlorine. So I'm going to take 26.1%, and I'm going to make that grams. And I'm going to convert this to moles of chlorine. Okay, that means grams of chlorine have to come down here. 1 mole of chlorine, its molar mass is 35.5. Again, we keep it at the half. We do our normal rounding up or down if we needed to, but if there's a half of a gram in the molar mass, we keep it. So 26.1 divided by 35.5, we should get 0.7352 and a bunch more numbers, and that is moles of chlorine. Okay, so I've done step 1. I've changed the percentages to grams, and I converted those to moles. now I divide all of these values by the smallest number. So the smallest number here is going to be my 0.36857. Okay, and when I do this, this is obviously going to give me a value.
Laura, we have more of your flowers here.
This is obviously going to be a value of 1. Okay, we'll talk about what that number means here in a second. And then this is going to be divided by the smallest value again. When I do that, I'm going to get an answer of 2. Okay, so what does this mean? The empirical formula, if I have these percentages that are calculated out, I'm going to have 1 atom of mercury and 2 atoms of chlorine. So it would be HgCl2. That would be the empirical formula of this. Now, one thing to remember, and students get this mixed up, if I don't write these out in a specific order, which one of these goes first? If you remember, the positive ion, if it's a metal, goes first. Okay, so that's why mercury has to be written first before chlorine. Okay, so make sure you're double checking that. That's the compound rules. Okay, so again, if you want to pause it, try this one out on your own. But let's get after it. Okay, so this one is, we've got 69.94% iron. I'm going to do the same thing, and I'm going to make that into grams. Okay, so 69.94 grams of iron. We're going to convert this to moles of iron. Okay, so I have grams down here. So 1 mole of iron has a molar mass of 56. Okay, when I divide this out to reduce it, I get 1.2489 lots of numbers. Okay, so that's moles of iron. Okay, so now I'm going to take 30.06% oxygen, a compound that has these ratios. Okay, I'm going to take 30% and make that into grams, and I'm going to convert this to moles of oxygen. I'm going to have grams of oxygen down here. 1 mole, the molar mass of oxygen is 16. Okay, 30.06 divided by 16. My number should be 1.87875 more values. Okay, so that's moles of oxygen. Okay, I'm going to divide, so I'm on step 2 now. Divide all values by the smallest. The smallest is our iron number. So obviously, when I divide this by itself, we are going to get 1. I'm just putting the exclamation point just to kind of drive this home. Okay, you don't feel like you have to put that. Okay, divided by 1.2489. When I do that, my answer is going to be 1.5. What do I do with that? I cannot have 0.5 of an atom. So to get rid of that, the trick is we need to multiply this. Okay, so if you get an answer of 0.5, 1.5, 2.5, the trick is you must multiply that by 2, everything by 2. So if I multiply this by 2, that means I'm going to have 3 whole atoms, and then this is multiplied by 2 is now going to be 2 whole atoms. And so the ratio for this, that's a trick to get rid of that. Okay? So the ratio for this compound would be 2 irons, Fe2, and 3 oxygens, O3. That is the empirical formula that we would have with that. And if you guys remember, iron oxides, iron can play a couple different roles. And so these calculations are going to help us to figure out the empirical, the most reduced atom of that. Now, one last thing. If you get answers here that have, instead of 1.5, let's say it's 0.3 or 0.13 repeating or 2.3 repeating. Okay, what would we multiply by to make those numbers whole? We would multiply those by 3. Everything would be multiplied by 3. So, I hope that gets you going on the empirical formulas. You need to have this down to be able to do the next piece, which is the molecular formulas.